Our next speaker today is Srinivasan. Srinivasan is a long-time Python programmer. He's built various text data analytics products, distributed and scalable system. He's worked with different Python web framework. Currently, he's working on his own startup, and he's also working as an independent software consultant. He was here during the first PyCon India. He was talking about schema-less data store built on top of RDBMS. He's also given numerous talks in other events and universities. He's also organized a few hackathons, tech and entrepreneurship events in Chennai and San Diego. Let's welcome Srinivasan.
Thanks. You guys can hear me? Yeah, you can hear me now? Now? It's okay? Okay, fine. So, my talk is about building scalable distributed systems using ZeroMQ. And let's start with a basic web framework tutorial. So, whenever you see a new web framework, you will write a wiki or a blog application. And this is how it is, right? So, there is a application server and there is a client. That's your browser. And you send requests to the application server and you get responses back. But when it comes to the real world, it becomes slightly complicated. Like if you need to build a product which is facing customers, you would need various other components, like maybe you want to send your SMS or emails whenever a customer buys something from your site, or you need to send automated alerts whenever your customer does something on your site. So there are various other components, like if you are running a social network, you would need to like resize the images that your user uploads, resize them, generate thumbnails out of it, and so on. So all these components need to fit together, and the easiest way to do that is to use queues. Like most of these problems can be solved by using queues. And whenever you search for message queues on Google, you would get the few basic things like Apache ActiveMQ and RabbitMQ, StormMQ. All these three uses the advanced message queue protocol, which is like a heavy-duty protocol, and these require a message broker, that is a big server through which all the messages from your client goes through. Client and the server goes through. So if there is a web server and an image resizing component, the message or the image URL goes through the message broker and it is sent to the component, so the image resizing component. So this is like, you need a very robust and stable machine for this message broker. So if this message broker goes down, your entire system is like will fail. And or you can like whenever I do a search for this and I see that I have so many options, I end up using like Redis Server. So Redis is like a data structure server, and you can use it as a queue. It has facilities for publish, subscribe, and so on. So there are a lot of data structures that you can have on Redis, but you can use it as a queue. But there's one more MQ that is like very prominently seen on the Google search results, like that is ZeroMQ, and it is strictly not a message queue. That's why the ZeroMQ is. So there is no message broker, and there is no central point of failure for your entire component. And the zero also denotes that your application or the entire product is has zero latency and is quite fast. And like the AMQP, that protocol was written by a big group of companies for handling financial data. Like whenever you have stock market data that needs to be sent to its members or various consoles, you would use this AMQP. One of the company was Imatix, and they started the ZeroMQ project, which has similar goals like AMQP. So to use ZeroMQ, there are various patterns that you can use, like the basic request reply pattern, that is the client sends a request and the server sends a reply. Or you can use publish subscribe, and you can pipeline your tasks to multiple systems, and you can like distribute tasks to various workers. And there is also another pattern called as paired sockets. So I'll just explain the code for the first three patterns, which are the basic patterns that you would end up using in ZeroMQ, and you can like use multiple patterns together with each other. So let's start with the basic request reply pattern. So you have the server, which waits for any request from a client. So the client will send hello, and the server needs to send world back to the client. So this is what we are trying to see now. So for this, I have a hello world server. So it's very simple. You just need to import ZeroMQ, and you need to create a context. That is ZeroMQ.context. This is required because if in case you are using another module or a package that has ZeroMQ, this context separates that module's context. So you need to create a context before you start creating your socket and binding in. So I create the context, then I just print a starting hello world server, and I create the socket. So creating the socket is just context.socket, and what is the type of socket I need. So this is a ZeroMQ.reply socket. So this socket is used to send replies back to the client. And after you create the socket object, you bind it to a protocol. Say for this I am using TCP protocol, and it's running at it should run at the port 5555. So I just created a socket and I bound it, and I run an infinite loop which just waits for any message that is sent to the socket. So the socket.receive will just block till it receives any message, and once it has received a message, it will print okay, I got this message, and it will send back through the same socket the response, that is in this case the world. So this is a very simple server, and let's see the client now. The client is also very simple. So you create a context object and you create a socket. The socket type in this case will be a REQ, that is a request object, request socket, and you connect the socket to localhost and the port at 5555. So once this connection is established, I just loop through for 10 times, and then I just send hello, hello, hello for 10 times, and I just print the response back. So I use socket.receive for getting back the response from the server. So I'll just show the demo for this, and the left hand side will be the server and the right hand side will be the client. So okay, so okay, the client has started, but usually when you start a client or you go to your browser and hit google.com and or some other website and the site is down, you receive a cannot load page, right? But it says connecting to the hello world server, but it hasn't still thrown any error. So let's see, Python HW server works. So I just started the client first, and then I start the server, and it works. So ZeroMQ handles any order of socket creation and binding and connection. So you can create your client first, then the server. You can create the server first. You can start the server first, and then your client. Everything will work. So what the client does is it creates the socket. It connects to it, and it assumes that there is going to be a server at localhost 5555, and it will send the first message socket.send. It will keep blocking at socket.send till it hits a server at 5555. So the client, even though we started the client first, it will keep on blocking till it finds a server, and that's what we saw there. So let's take a different example of the client, that is, which sends data in an infinite loop. So the first part is same. Then we do a while true loop, and I take the message to be sent from the command line arguments, and I send it through socket.send, and I receive back the message, and I print it. So the last part is where I ask the client to sleep for a few seconds. So in this, I will be starting two clients, a single server, and let's see how the server handles both the clients' requests, and it load balances between the two clients' requests. So I have two clients on this Python HW client. First argument is the seconds that it needs to sleep. I'm sleeping it for 500 milliseconds and sending the message hello. So every 500 milliseconds it sends hello, and you can see the output on both the client and the server. So let's start the second client. It is client.py, and in this I'm going to sleep for 100 milliseconds, and let's send a different string. Okay, I need to activate the environment. So this client is sending a different string, jello, and that client is sending hello, and the server handles it automatically. So this is like for every one request from client 1, it receives 5 requests from client 2, and it is like it automatically load balances the messages that it receives from any number of clients. I can start like 1,000 clients here, and it will automatically, the server is capable of handling all the 1,000 clients in the same order the messages are received. This is because the ZeroMQ library creates a queue, a very lightweight queue on both the server and the client end. So all the messages that are sent by the client is automatically enqueued in the server's end, and whenever the server can handle it, handle the request and send a response, it will handle in the order that it arrives. So I can like I can increase the speed of this. Say I want to make it very fast. You can see that it still works. You can handle like millions of requests at the same time, and it should handle pretty fast. So I'll just kill this. And this is the basic request reply pattern. The second pattern that we'll see is the publish subscribe pattern. So this publish subscribe pattern is where you have a server and you have multiple clients. The server publishes a message, and this message is sent to all the clients which are connected to the server. So you have you bind it on a socket of type pub, and the clients will create a socket of type sub, and it will connect and it will receive updates. So let's this pattern is very useful if you want to like create a chat room. So any message from a single user needs to be sent to all the users connected to the same chat room. And you have a central server which receives this message from user 1, and it sends the message, it publishes the message to all the users connected in the room. So the other use you can see is when you want to like receive updates from a stock exchange. Let's say you have a stock exchange and you want to send updates about various stickers, various scripts, and you need to receive them, that is the members need to receive them via the client. So I just created a very simple stock ticker server. So it's the same stuff, like you create the context, you create the socket of type ZeroMQ.pub, and you bind the socket at 5556. So it's a different port. And I have a list of scripts like Apple, Google, Microsoft, Amazon. So the while true loop, it selects from these 4 scripts, it selects a single script randomly, and it chooses a price randomly between like 20 to 700, and it sends this message. So the message will be like AAPL space 600, GOG space 300, and so on. So it randomly selects both the scripts and the price, and it sends this message to the socket. And any client which is connected to this socket at 5556 will receive this the message that it publishes. So the client is very simple, but you need to remember one thing, that is the client doesn't require, it's not mandatory for the client to receive all the updates. It can choose to subscribe to only a specific message. Like if you are interested just in the stock prices of Apple, you just subscribe to AAPL. That is the first string of the first part of your message string, and only messages which match the string will be printed or will be received by this client. And there is a way to like subscribe to multiple messages. That is that's what I'm doing here. Like I'm taking the list of scripts here and from the command line arguments, and for each script in the script list, I create a socket option. That is, I subscribe it and use this message string. And the while true part is the same. That's you receive from the socket and you just print it. So I'll just do a quick demo for this. This is the server, and it randomly selects a script and a price, and it just sleeps for a few seconds and few milliseconds, and then publishes it. Right now, there's no client connected here, so this is like a radio broadcast, and it keeps on sending these messages. Even if there is no one to receive it, it will send. The server will send. It doesn't care about that. So let's start the client. The default client is subscribed for Apple AAPL. So it will just print whatever messages that it receives which match AAPL as the first string. So let's start another client with Microsoft and Amazon for the scripts, and it should automatically filter out only these 2 scripts. So you can connect any number of clients to this server, and it should handle it automatically. So this is a very simple publish subscribe pattern, and let's go to the third pattern that I would like to discuss is the parallel pipeline. So this is where you can do distributed tasks. Say you want to process an image that a user uploads, and if let's take for example the user uploads 100 images to an album, you don't want to you don't want to resize it or create thumbnails one by one. it's easier if you have like 10 servers which are running parallelly, and you can automatically send the images to all the 10 servers and get it done in like 1/10 of the time. So you have a ventilator. The top one is like the server, which creates the tasks and it sends to the various workers. The workers are right now, let's say, have 3 workers for this, and the workers pull from the ventilator, and it pushes the result after it has done the processing to the sink. The sink is where you would like say you want to store the images to some file system, or you want to send a message back to the user saying this is the images that you have uploaded, that kind of thing. So the sink does that. So a quick demo, and for this we will be using anti-gravity from XKCD. Like, the task is very simple. So I'm going to loop through all the XKCD comics from 1 to say 1 to 10, and I want to extract the title of this. So in any XKCD comic, if you hover over the image or the comic, you would get the title. So I want to get the title out. So this is the ventilator or the server which creates the tasks and pushes them to the workers. And you create a sender socket which is of type ZeroMQ.push, and I bind it to a new port, say 5557, and I just ask for the user to press enter after all the workers are ready. This is required because if, let's say, if I don't have this raw input statement, it will just send all the URLs to the workers, and even though there are no workers started at the beginning, the moment I start the first worker, this first worker will get all the URLs, and you wouldn't be doing any distributed processing. So first I will wait for the user to like confirm that all the workers are available, and then I will send the URLs. So the URL is very simple, say xkcd.com/1/2/3. So I just take the command line arguments for that, and I'm going to process the first 10 comics. So the second part is the worker. The worker, I have a get title function which does the actual work. So it uses a request module, and it passes the XML, and it does all the magic and gets back the title if it can find the title. If it can't find the title, it will just return a none. So this is the function that does the actual work, and this is the part which is below that, and this is where you create the socket, and you do all the sending of messages, receiving messages. But in this, we will be creating 2 sockets. That is, one is the receiver socket, which receives tasks from the ventilator, and the other is the sender socket, which is the socket through which it sends to the sink. So I first receive it from receiver, store it at yes. I use the getTitle method to get the title, which is a string, and I'm just printing both the URL and the title, and then I send a JSON dump of the URL with the title to the sink. So this JSON URL, this JSON payload will be sent to the sink, and the sink can like store it in any format that it wants to. And the sink is very simple, and it just receives the JSON payload and it prints it. It's very easy. So receiver.receive and then print the string. Let's do a quick demo for that. Python XKCD ventilator. I started the ventilator, and I need to start the workers, and I will start 2 workers in this example. Python one second. The ventilator requires a command line argument, so I will kill this and select the first 10 comics. this worker is already created, that is, it is started. I am starting the second worker, and I am starting the sync. So all the components of XKCD title downloader is ready. So I just have to press enter here, and the ventilator will send 11 URLs, which are fairly scheduled between the two workers, and the workers will download the comic, download the page, and get the title and push the JSON data to the sync. I will print all the things that a particular worker does in the respective consoles. So I have sent the jobs, and we can see that the two workers have done the work. Like the odd numbered comics are sent to one worker, and the even numbered comics are sent to the second worker. And both these workers, after they're done with the job, they push the JSON to the sync, and it just prints the JSON. Or the sync can choose to store it in some database or something. So this is a very simple distributed task processing system that you can build with ZeroMQ. And these are the three basic patterns that if you can understand these three patterns, you can create multiple patterns that that can solve a lot of your problems in building distributed processing systems. And the best thing about ZeroMQ is you're not bound to use a message broker, and you like the end components handle all these message queuing and all this stuff automatically. So what are the other features of ZeroMQ? That is, you have a lot of transport protocols, and the one we saw was TCP, and you can it's a basic protocol that you can use over the internet or any LAN or WAN. And the first two are in-proc, that is in process. So you have a single process, and you have like 100 threads in that, and you want to communicate between these threads. You can use in-proc protocol, or you can use IPC, that is inter-process communication. If you have multiple processes running on the same machine, you can use the IPC transport. And the PGM or EPGM is multicast, is a very smart multicast protocol. So it is very similar to the publish subscribe pattern that we saw. But the problem with PubSub was, if let's say per day I am sending 1 GB of data, the stock exchange is creating 1 GB of data, and there are 1,000 clients connected, I would be sending the same copy to every client. So I would end up sending 1,000 GB of data. So the multicast protocol does this smartly, and it sends one copy of the data, and the clients handle them automatically. And it's available not just for Python, it's available for a lot of languages. Like there are almost like 40 languages that it supports, and you have libraries for all these, and you can just try the same program that I showed you can work with multiple languages. So the worker can be in Python, the sync can be in Java, and the task ventilator can be in Ruby. So it will all work automatically, and there's no problem with the message frame, the messages that are sent and received. So this is the basic talk, and for more information about ZeroMQ, you can go to zero.mq, which is a basic site, and I highly recommend the zguide.zeromq.org, which is like a huge page of guide, which is like you can print it out as a book, and you would have a lot more patterns and various other things that you can do with ZeroMQ. And by the way, the code examples that I showed is available at GitHub. I have uploaded to github.com/cnu/0mq/talk. So I'm done with the talk. So if you have any questions or if you want to discuss more about this, yeah. Yeah. Mm. Yeah. No, so his question is like, if let's say in midst of the task being executed, if one worker goes down, will the task be automatically scheduled back to another free worker? That's your question, right? So it doesn't do that, because once the ventilator sends the task, it is gone from the ventilator's queue and it is now sitting in the worker's queue. So if you want to handle that, you can have a copy of the unfinished tasks in the ventilator, and then you can, once the task is sent to the worker and it has completed and sent to the sink, then you can kill the work from the ventilator. So you can do, the good thing about this is you can handle these kind of error conditions or exceptions by using your own code. And it depends on your business logic, right? If, let's say, images, it needs to be processed, you will need such kind of logic for that. But if there are some other, let's say, if there is a crawler that is automatically scheduled every 1 hour, and it doesn't matter if you don't crawl it the first time and you lost like 100 URLs, so you will automatically crawl it the next time. So these kind of things, it depends on your business logic, and ZeroMQ does that, leaves the user, that is the developer, to handle all these. So.
Yeah. My question continues on to that.
Yeah.
A lot of times these kind of messaging systems have extremely strong supervision systems to figure out if somebody has gone down.
Yeah.
What to do if some worker thread was to go down? Should you restart it? Should you kill the guy who sent the message in the first place? Should you shut down the whole? So there's reasonably sophisticated supervision systems, because I assume here. You talked about the other message queues. They are persistent. They are transactional. Yeah. Here you have none of those capabilities, which means you need to know if any worker goes down. Otherwise, you're just shooting arrows in the dark and they're not landing anywhere. What are the nature of supervision systems available for this particular infrastructure?
For ZeroMQ, by default, you don't have any of these supervision or monitoring tools. Like that is the whole idea. If you have a message broker, it will handle all these. Like AMQP. Requests a message broker which can do this. So the point of ZeroMQ is like, it's not a message queue, but it is a transport, it's a networking library, and that's what it does best.
I mean, just as an alternative, for example, Erlang virtual environment, it's not a message queue. It has these characteristics.
Yeah.
But then there is a supervision infrastructure which tells you whenever processes die. And
which one? Sorry?
Erlang.
Okay.
You talked about Erlang being one of the clients somebody can use, but the supervision part becomes important because there is no fallback. There is nothing else.
The supervision will be done by your program. So you need to write the code for the supervision, and you can like make it very stable enough if your business case requires that, or you can make it very lenient, and even if it loses a few messages, it is okay. Then you can vary the leniency for this. That's the advantage of ZeroMQ.
I have a question.
Anyone? Yeah.
So you said that we have APIs in multiple languages. So if I am sending a ZeroMQ message using Python, is it possible to read it in some other language? What's the wire format?
Is it possible to?
Is it possible to read it using some other language, like a Java client?
Is it possible to?
You have a Java client which is sending a ZeroMQ
like I said, the worker can be in written in Python, or it can be in Ruby, and the ventilator can be in Java. So the Java program will create the message, and it will send to the Python program, and the transport is handled by ZeroMQ.
Okay.
So if you send hello from Java to Python, it will be received as hello. You don't have to worry about.
What will be the format which will be used?
So ZeroMQ adds a very minor number, that is the number of bytes the message consists of. Let's say hello, you would the ZeroMQ will add 5 HELLO and it will send that as the message.
Okay.
So it's very minimal amount of overload that you have over the message. So that's why it's very faster than other AMQP or those kind of things.
Okay.
That's it.
Yeah. There's a new port called a nano message.
Yeah, it's a fork of ZeroMQ because there was some problem with the founders. There are 2 founders for ZeroMQ, and one guy left and he started nano message. But it is just it's in very early stages, and I don't know if it is like worth going into that. So ZeroMQ is properly documented and it works fine, and a lot of companies use this for financial things and even for logging, those kind of things. So ZeroMQ is like pretty stable enough to use.
A question here. Here.
Where?
Hello.
Yeah.
So from all of the discussion, what I was trying to gather was it's a very light framework where management and monitoring are very limited or non-existent. So it's purposefully so the case, I believe.
It's purposefully designed like that.
So what's the tool to problem match on this? Which kind of problem should we solve using this particular tool?
If you want to send and receive messages very quickly, like if you want to send millions of messages in a few minutes, this is easily like the best tool that I can see. You can use AMQP or the other message brokers, but this is like if you want a very lightweight and something which can handle even gigabytes of data, you can easily send a single message which is like 1 GB of data, and the clients or the servers can easily handle it. So that's the use in this. Yeah. Yeah. So his question is like how much memory does it take for handling the messages? All the queue is in memory, so every message that you send is stored in your memory. And like if I said, if I sent a 1 GB of data, it needs to have 1 GB or more than that to handle that. But the problem with such high data, right? So ZeroMQ handles it differently. So there is a high-level watermark for every socket that you can have. So whenever that high watermark is reached, the sender or the receiver will just simply block, or you can change it to just discard the message or so on. So whenever you run out of memory or the number of messages is very large, like if you are sending 1 million messages and your workers haven't yet finished the whole task, so it will just block, the ventilator will just block and wait till the workers are done. No, it will not grow. You have all these subscribers on different machines, or? It can handle pretty well. So even if you have a million subscribers to a single publisher, or like you said 10 publishers, it will automatically handle this. The library is designed to handle these kind of large scale systems.
Okay, we've got to cut in, sorry, but this is the last question. After that, there's going to be a few minutes when the next speaker has to prepare.
Yeah.
So, yeah, please go on.
Yeah. So you want to like, yeah. You can, these 3 patterns are very basic patterns that I said. There are even more types of sockets that you can create, like dealers, routers. A lot of stuff can be created. So if you check the guide, you will have like every possible combination that you can think of is explained in the guide, and how to write your program with that. So it's quite well documented, and you can check that.
Yeah.
Thanks.
Thank you.